Right, so today we're talking about absolute value problems. And I'm going to start out by defining the definition of what is absolute value. What do we mean in math when we say absolute value? So absolute value of a number is shown with two vertical lines. So x is just going to stand for any number here. So this we would read as the absolute value of x. Okay. Absolute value means how far the number is from 0. Okay? So how far x is from 0. Now, for a lot of numbers, that's just the number. So if I said, what is the absolute value of 3? How far is 3 from 0? 3. So the absolute value of 3 is 3. What is the absolute value of 7?
7.
What's the absolute value of 1,753,000?
1,753,001. Wait, no. You got a 0.
Yeah. So for any positive number, the absolute value is just that number. Absolute value is going to be different when we have a negative number. What is the absolute value of negative 3? How far is negative 3 away from 0?
Negative 3 away.
Well, just how far? All I'm asking is the magnitude. What is the distance? Yeah, it's just 3 units away. Right? So the absolute value, the idea here is we don't care what direction from 0. All we want to know is how far is it. What is the absolute value of negative 7?
7.
Positive 7. Yeah. So the absolute value of a negative number is just the positive version of that number.
So it's always going to be a positive.
Right. So the answer to an absolute value shall always be a positive number. That's right. Okay, now, how does this show up in algebra? It is going to show up like this. Let's say I have a problem. Usually, let's say I said the absolute value of x equals 7. So I'm trying to solve for x. What is x if the absolute value of x is 7?
It's 7 as well.
Or, yeah, so x has to equal 7 or negative 7. Because the absolute value of 7 is 7, and the absolute value of negative 7 is also 7. What do you notice about this? I have how many solutions?
2.
I have 2 solutions. So absolute value problems in algebra are going to have 2 solutions. Just about always. Okay. They get a little bit more complicated. What if I asked you for the absolute value of x plus 2 equaling 13? So you could try to figure this out in your head, but there's an easier way. We're going to take what's inside the absolute value, x plus 2, and we're going to set up 2 equations. Either x plus 2 has to equal 13, or x plus 2 has to equal what? Negative 13. Now I can figure out what x has to be. So if x plus 2 is 13, subtract 2 from both sides, what is x? 11. Or subtract 2 from both sides over here.
Negative value.
X would be negative 13 minus 2. So I'm over here on my number line, right? Here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm over here and I want to go minus 2. What number would I be at? Yeah, negative 15. And those are my solutions. Either x equals 11 or x equals negative 15. And that's it. So the only new step here is this step. When we see the absolute value, we write two equations and we say or. Either this equation or this equation. Okay. So let me give you another one. What if I had 3x plus 2 inside my absolute value equals, actually, I don't want to do 3x. That'll be equals 12. So 2x plus 2 equals, sorry, the absolute value of 2x plus 2 equals 12. What is my first step going to be? Okay, that's one equation. Or, what's my other equation?
2x plus 2 equals
Good. Negative 12. Right? Because if this is negative 12, the absolute value is still going to equal 12. Alright. How do I solve this one? 2x plus 2 equals 12. What do I do to solve it?
Subtract 2.
Uh-huh.
2x equals 10.
2x equals 10.
And x equals 5.
Right. By dividing by 2?
Yeah.
So x equals 5. Are we done?
No.
No, because we have this whole other equation. We're going to solve it the same way. Subtract 2. What is negative 12 minus 2? Negative 14. Very good. And then divide both sides by 2. What do we get?
X equals negative 7.
Very good. And now we're done. We have our two answers.
So you're supposed to have 2 answers every time.
Yeah, pretty much. Okay. Questions? I'm going to add one more thing. So, there's one other step here. So what if I have x plus 1 in the absolute value, but then I have something outside of the absolute value? Maybe I have like a minus 7. And then that equals 15. This is going to be a little bit different. The first step is to get the absolute value, that whole thing, alone. So just like we try to isolate x, here we're trying to isolate our absolute value. So how do we get this alone? Right now we have this minus 7.
You add 7?
Yeah, the first step here is to add 7. Now I have just the absolute value of x plus 1 alone on this side. And on the other side I have 15 plus 7, which is 22. Now I can go back to that other step that we just learned. So what do I do? What's my next step?
X plus 1 equals 14.
Uh-huh. Or
x plus 1 equals negative.
very good. All right. How do I solve that?
Subtract 1.
Subtract 1. So I have x equals 21, or
Or x equals negative 1.
what is negative 22 minus 1?
X equals negative 23.
Negative 23. Yeah. very good box, but
I did that one.
okay.
Yeah.
So let's review those steps. Review the steps. I want you to write this in your notes. Step 1. Isolate the absolute value. Step 2. Write two equations. Step 3. Solve both equations for x, or whatever your variable is. It could be any variable, right? My markers are kind of faint. So let's do one more problem. What if I have this? 3 absolute value x, 2x minus 1 absolute value plus 6 equals, so before I even write what that equals, what is my absolute value here? What is inside the absolute value?
2x.
Right, so I know that I'm going to have to get rid of the 6 and the 3. Does that make sense?
Yeah.
Okay. Equals 24. I'm going to actually change this a little bit. Minus 2. 2x minus 2. Okay. So step 1, isolate the absolute value. Do I get rid of the 6 first or the 3 first?
No, 3 first. Wait, no.
Think about if this were 3x plus 6. What would we get rid of first?
Next 6.
Yeah, we would get rid of this thing over here. We have to do addition and subtraction. We have to reverse that first. So I subtract 6 from both sides. Now I have 3 absolute value 2x minus 2 equals 18. Now what?
Subtract.
So this is something that we haven't really seen before. The 3 next to the absolute value, it means 3 times. Yeah, exactly. So we're going to divide by 3. And so now I have 2x minus 2 equals 6. Can I go on to step 2? Can I write two equations? Look at my left side. Is it just an absolute value? Nothing outside the absolute value?
No. Well,
Oh, that crosses out, so it stays there. Okay.
Yeah, the 3 and the 3, right. The 3 divided by 3 crosses.
That was the one you were.
But look at it now.
Yeah.
This is just an absolute value here, right?
So
There's nothing in front of it. There's no 2 or there's no 7, whatever. There's nothing being added or subtracted. So now I know that I can go to step 2 because I just have this absolute value. So now I'm going to write my two equations. 2x minus 2, that's what was inside the absolute value, either equals 6 or what's my second equation?
or 2x minus 2 equals
Negative 6. Okay? How do I solve this first one? 2x minus 2 equals 6.
You
Add 2 to both sides. Now I have 2x equals what? 6 plus 2?
8 equals
8. Divide both sides by 2.
Oh, yeah.
X equals
4.
4. Or, how do I solve this one over here?
You add 2 on both
Add
sides.
2 to both sides.
And then your
2x
answer was
equals, what is negative 6 plus 2?
negative 3.
Close. So I'm over here. 0, 1, 2, 3, 4,
Yeah,
5,
negative
6.
four.
Negative 6. I'm going to add 2, negative 5, negative 4. And then what?
Then you divide by 2.
Very good.
Equals negative 2.
X equals negative. So either x equals 4 or x equals negative 2.
It's a long problem.
Yeah, when they get this with all these numbers out front, they do get kind of long. So when you have a long problem like that, it's worth it probably to check your work. So let's plug these numbers in and see if this actually works. Our original problem said 3 times the absolute value of 2x minus 2 plus 6 equals 24. We think that x could either be 4 or negative 2. So let's make x 4. Now I'm going to evaluate this. We have 3. What is 2 times 4?
8.
8. 3 times the absolute value of 8 minus 2. What is 8 minus 2?
6.
Yeah, so 3 times the absolute value of 6 plus 6 is supposed to equal 24. What is the absolute value of 6? 6, right?
Yeah.
Because it's how far it is from 0. So 3 times 6 plus 6 equals 24. What is 3 times 6?
18.
18. 18 plus 6 equals 24. Is that true?
Yeah.
18, 19, 20, 21, 22, 23, 24. It is true. So this one checked out. That worked. Now let's try doing it with the other number that we thought, which was negative 2. So to check our work, we're going to plug in. We have 3 times the absolute value of 2x. But instead of x, we're going to put negative 2. Minus 2 plus 6. Can this also equal 24? I mean, this is a totally different number here. Let's see. So we're going to start out inside our absolute value. Inside our absolute value, we have 2 times negative 2 minus 2. What do I do? How do I figure that out?
Oh, you multiply the 2 times the negative.
And what is 2 times negative 2?
Negative 4.
Negative 4 minus 2 plus 6 equals 24. Okay, now the order of operations says multiply next, but the trick with this absolute value is like parentheses. So we always have to do what's inside the absolute value before anything else. So inside our absolute value we have negative 4 minus 2. What is negative 4 minus 2?
Negative 6.
Yeah, negative 6. So we have 3 times the absolute value of negative 6 plus 6. So I still have an absolute value. I can't really go on until I get rid of that. What is the absolute value of negative 6?
6.
Positive 6. Very good. So 3 times 6 plus 6. What do I do first? The 6 plus 6 or the 3 times 6?
3 times 6.
Yeah, always PEMDAS, right? So 3 times 6 is
18.
18 plus 6 is 24. Is that true?
Yes.
Yeah. So they both worked. Both of our solutions gave us a correct equation, right? A true equation. And we just checked our work. Very good. All right. Questions? Preguntas? Yeah. Okay. Uh-oh.